The last speaker of today is Holger Krekel, who came from Germany. He has been active in the community since 2002. He's the co-founder of PyPy project and maintainer of talks, pytest and devpi. Holger will discuss how we can decentralize the web. I give the floor to Holger Krekel.
So thanks for having me. I think I'm going to try to actually see something. The talk title is actually Stories about Decentralization and Diversity. And I see some relations there. So for those of you who are wondering what I'm doing like lately, in the last 2 years I went around quite a bit in different communities, and not primarily Python communities, and discussed with people about what's going on in terms of decentralization. And for me to get an idea actually on where you stand basically on this issue, and if you have some thoughts on this, how many of you think actually that the centralization that we have in the web, which I'm going to talk about a bit more, is a problem? Yeah, I will define this in like various ways, yes. Okay, so I can ask the question again. So this was like a third, maybe. But first I want to start off with some things that I find important in terms of thinking about this concept of diversity. You probably know that the Python Software Foundation and many other conferences went into this code of conduct and many other activities, especially in the PyCon US. There's this outreach program, and they basically managed, I wasn't here at the talk, maybe you mentioned that, I'm not sure, but that kind of like over the years, the participants from women in the US was like, first it was like 10%, then 20, then 33. I'm not sure what the last PyCon was, but probably also around this. And that's also true for the talkers, and that's because they actually went out. Oh, who's thinking I'm talking too fast? Okay. I'm actually amazed that we have this like conference in Poland with many people from Warsaw, and you choose to actually do it in English, just for the few of us who don't understand Polish. Thank you. So 2 weeks ago, I came across this thing, which is the World Comic Day. It's kind of like a coordinated action and for many groups around the world on like celebrating comics and novels that are told in pictures. And I saw this, and I thought something is strange about this. I always have this feeling. I look at something and I think something is strange about this. So I'm just giving this around. Just take it and pass it on. You will see, when you look at that, I'm not sure if you would normally notice, but what you can do actually is you can count. These are like 40, 50 figures, like painted figures, right? And you can see that there's around 30 men out of these 40. Then there is something like 5 animals, 3 vegetables, and 2 women. I think YouGov is actually doing much better. I think I just did a quick count. It's like 65 to 35 or something like this. And you can see examples like this like all around, and all around the world basically, not just in. So it's not this topic basically of diversity. It's not just one that affects IT communities. It's a very very large topic, and a very present topic. The thing is that when we think about, when I tell you, for example, about this great engineering program that they did in the 60s to actually fly a rocket to the moon, they had software, right? They had like software and machines that had less power than what you have in a Raspberry Pi. But they still managed to actually fly this thing and have an automated guidance system that actually prevented a crash automatically when they went to the moon. And there was like this very great programmer who did this, who was like the head of engineering. So when you hear this, just like this, then what is the mental image that you basically have, like when you think of that, right? Yes, a basement of nerds and, you know, some guys doing some stuff. So the head of engineering was Margaret Hamilton, and she actually was like the lead designer on all of that program for the engineering. And there's like many examples like this. And the problem is that when I tell you the word doctor or pilot or all kinds of, you know, titles, then when we hear a word, we actually have some kind of imagination of this, what we assume this person to be, like how it looks like maybe, or some kind of image. And that kind of imagination that is triggered by words and like our interpretation of what they mean and what kind of pictures are involved, they are biased. They have a certain, like we prefer some pictures over others. And how this comes about is not a topic of computer science, but it's a topic that is very important also in computer science. So when we have language, we kind of like, and that's also partly true for computer languages, when we have language, we use words, and we have some kind of normalized meaning for things. And that might be very wrong, actually, applied to the concrete person. And the language as a centralized system, like English, what we're using now, for example, helps us across diverse languages to communicate. So we have like this centralized language, and because we are using it, we can all interact, right? If you use like different languages, then it would be much harder to just arbitrarily interact. So that's an interesting observation already, that you have like a centralized platform in order to actually enable peer-to-peer, like arbitrary communications between things. So many people, between humans actually, many people actually think of something like Google or Facebook as a centralized platform. But there is, if you actually think about it, there's this fact that Facebook is kind of like a framing, and then within that, people socially interact with one another, right? So it's decentralized, actually. The actual social interactions are decentralized. YouTube is a decentralized platform in the sense of the social interactions that happen between people. And it actually goes back to the Middle Ages. Like when you create a market and people, like a central market in your village, you have this central place, but then people actually come there and they interact however between each other. You just have the framing, and within that frame, people like interact in all kinds of ways. And that's a topic that goes like for a very long time, and we are in a situation where we have actually these kinds of platforms on many levels, like YouTube, Facebook, Google, and so on, but they are all about decentralized interactions between people. So that's kind of a strange thing. And I think it's because when we are coming from computer science, we have some kind of X-ray view. Like we see this, and then we look at the network topology, and we know about DNS, and we know about, okay, this company actually operates the server, you know, and even though all of the interactions are actually peer-to-peer, the social interactions like sending mail and whatnot, they're all in one central place, owned by one entity that actually can keep track of everything. And this kind of like development we had in the last 6-7 years in a very big way is, of course, not just happening randomly. It's not because technically it's the most efficient way to do things. It's because this kind of tracking actually gets you money, right? So you can actually get venture capital for doing a service. People come to you, and you can track people. And that's what all these platforms are doing, basically. And you can sell the profiling data to advertisers. Because advertisement for a long time already is not about just selling anonymous masses. You actually have like targeted groups you want to have. Give me all women that are between 28 and 35 and have a certain income and send messages to them. That's what the advertisers want to have. They don't just want to have like arbitrary advertisement. And that's kind of like some hints on how this got to evolve. So it's not a technical necessity that this happened, but it's the way how you can make money, how you can monetize. And for those of you who know about the history of open source, in the end of the 90s, Microsoft was the big thing, right? Open source versus Microsoft. And open source programmers were doing like lots of things and trying to replace proprietary software. And there was the problem, how do we earn money with that? You know, we can do this on our free time because we maybe earn some money in some other way, but we want to actually do this like on a more regular way. And then companies like Google and many others, including also the NSA, they actually went to all kinds of conferences and bought all the open source programmers. Like I was asked in 2004 at PyCon if I want to work for them. And they had like each of these companies had like 5 people going around the conference and like grabbing people because they saw the value of open source because they could actually monetize it. And people were happy because they got a great job at Google, you all know this. And this is kind of like how this whole development actually started. But what is interesting now is that the models that we actually got from this kind of development is like a very strong client-server model, right? At least on the surface of it. So you have like, you connect to a service, a web service, and then you, lots of users do this, and you coordinate basically the action. You are this central platform that allows kind of like arbitrary interactions, but you keep track of everything. The interesting observation now is that since a couple of years, that's not, it's kind of breaking. It doesn't work anymore. So Google and Facebook and Twitter and everybody, they have load balancers and they have like complex systems that have like distributed platforms, CDNs, content delivery networks that are actually often peer-to-peer systems behind. Like behind this kind of like central gateway or the central notion of going to Google, you actually go to all kinds of servers. So it is actually a distributed system, but still in control of one entity. But the reason why I say it's breaking, it's not because of that, but it's because of speed. The problem is that there are more and more devices, and for example, Apple and other companies, they had to invent their own protocol for synchronizing between devices, which does not involve going to a central service all the time. It's just too slow. Like if all Apple Watches and all iPhones went all the time to like some kind of Californian controlled service, that would be like wouldn't like really feel nice, you know? So they actually have like synchronization protocols between the devices, but this is not done via the web anymore. This is like the proprietary stack that they introduce. And many companies have done this. And then there is, since a couple of years, a lot of work actually that's going into making these kinds of systems where you actually synchronizing architectures, which are really a different thing than client-server architectures, into like the actual new paradigm. And that's happening, I think. In the last 2 years, I have been to 5 conferences that were not Python conferences, and meetups, sometimes small, sometimes larger. Like the smallest was like 30 people, the largest was 12,000 people at the CCC in Hamburg. And there is incredible work going on to actually get the decentralization that is actually technically happening back into some kind of web standard, or into some kind of standard that people can use. And one of the driving factors is the rise of hash-based data structures. So who of you knows Merkle directed acyclic graphs? Okay, who of you uses them? What do you think? Well, you all don't use Git? That's like the technology in Git, right? So in Git, hash-based data structures, and that's also tied to the rise of functional languages. And that's where you actually see that I'm kind of like cross-connecting or trying to cross-connect. I'm not claiming that I have like a complete picture. Hash-based data structures are used everywhere. Like when you have replication databases, then usually what you do is you have blocks of data. You have a content hash. Like in Git, for example, you have objects, what they call objects, and they have a header with like links. And then they make a hash out of that. And when you actually do a commit, you create a new object. You don't modify the old object at all. You create a new object, and that has a link to the hash of the old block. And then with this entry, you actually hash it again. So you have a new hash for this block. So it's just, you just append to the data structure. You don't change any of the existing objects. You just add another object that links to the old object. And this technique, these kinds of data structures, they're kind of like used in many, many places. Now, like BitTorrent uses this as well. And then there's the thing called distributed hash tables, which like, if you look at computer languages, there was this, this transition from like low-level data structures to linked lists and so on. And one of the big success stories of Python is it introduced a very efficient dictionary and list implementation. And that was like right there in the language, which is, if you came from C++, was like, oh, great. I can just use it. It's really fast. It's like super optimized, you know. But nowadays, these data structures have evolved because we have distributed architectures. So people had to think, how do we replicate state from A to B? And Git is like one big application, BitTorrent and so on, what I mentioned. And it's, these data structures are actually driving a lot of the current innovation in terms of synchronizing architectures. And there is now, the problem with these things is they're just in implementations, like Git uses them, and then many other projects have their own implementation of this. They also have their own implementation of distributed hash tables. And they also have like, there's currently like 100 or 200 startups on Bitcoin, which is also based on hash data structures, where you actually have like commonly agreed linked list, basically. Like Bitcoin is just a linked list. And it's just that everybody agrees, and you can regulate who can modify which entry. And that's it. Like on the data structure level, it's really simple. And what is happening now is that many people, and that's actually where I find the Node.js community, which I have interacted with a couple of people in the last 1.5 years, they are doing like really mad science about this, and they're making like very large progress. And when I'm saying JavaScript, I know that many people actually dislike the language if they compare it to Python, and I'm like one of the first to say that. And the funny bit was like in the last 2 days, I was in Berlin at like a 50 people meetup that discussed all of these technologies. And like half the people who do JavaScript there say, yeah, the language sucks, but well, that's what we have in the browser, and kind of like they take it from there. And they actually do like functional programming. So the things that we actually discuss here, they're also doing this, right? They're actually separating I/O from computation and things like this. And what they're doing is they're really, because they're very much into the web, right? So they want to have all of these things actually accessible from the browser, but not only from the browser, and that's the interesting part. So the biggest effort actually that is kind of gaining a lot of traction is a new internet protocol. So that was kind of like one of the main topics in the last 2 days for me. It's called IPFS. You can find it on ipfs.io. And it's a technique, basically it replaces HTTP, right? You would think it's crazy, we do HTTP all the time. But what IPFS does is it brings actually the Git model, which is content-based addressing. Like with HTTP, you have location-based addressing. You basically say in the first part of the URL, after HTTP, you say, this is the location, and then you ask some DNS servers, and then you finally arrive at some IP address, then you go there, and then you ask. And that's all kind of mutable state. The mapping can change, what the server serves can change, and so on. And you have to go to that location. And caching is a problem and whatnot. With content-based addressing, which is like bound to be something like IPFS instead of HTTP, you actually have a content hash, and that uniquely identifies a blob of data, because hashing works like this. If you have like a data blob, and you do a certain hash, like SHA-256 or others, then you get like a shorter identifier for that block. And if I send you this hash, you can't efficiently construct a data blob that matches this hash. So when I give you this hash and you ask somebody else to actually serve you the content, you can verify you get the correct content. Because you just ask, okay, give me the content for this hash, and then that other side sends it to you, and what you get, you actually hash it again and see if the two hashes match. And this kind of technique is used in Git and many other places nowadays. And with that, actually, if you bring this to the web, it means that you basically create a read-write file system that works on these content hashes. And you can even, and then what that also means is that caching is completely trivial, because the state behind that hash is never going to change. So when this thing arrives at your local computer, this content, you don't actually have to, you can just cache it, and the next time you need it, you just take it. Or if you want to have this data, you just ask somebody around you, some kind of device around you, and if somebody serves you, you can actually verify it's the correct thing and you have it. So with content-based addressing, or content hash-based addressing, you solve a lot of problems. And what I saw in the last 2 days were like demos, for example, where like Git itself, which many people use with GitHub, which is kind of like a central platform again, where people interact in a peer-to-peer way. But you still need to ask Twitter, okay, what's the current head of my repository? And then pull from there, like all the changes. With IPFS and Git Swarm is a usable project today already, which currently uses BitTorrent, not IPFS, but that's going to change. You don't actually go to GitHub anymore. You can basically update your repository from around you in BitTorrent. And that works already very well. And then there's this thing about intelligence moving to the endpoints. Like we have mobile phones, like 10 years ago, they were very dumb, but nowadays they actually run code, lots of code. There's like new computers which you can get like for $9, which are almost as fast as the Raspberry Pi. And so a lot of the intelligence and computations is going to move to the endpoint, and it's not possible anymore to actually always go to some center to actually interact. And through the content-based addressing scheme raised to some kind of internet standard, it's actually possible to interact with all kinds of nodes around you and work locally. One of the things that actually happens also is WebRTC, which does this browser-to-browser connection. And even though we might not like JavaScript, what's happening there currently is that they have whole applications I wanted to demo this actually, but the wireless LAN here is not really good enough. Because in this wireless LAN, we did this yesterday, we could just go to this page from all kinds of devices, and we would be on the same page modifying shared state, right? And you can, basically it's the whiteboard.webtorrent. WebTorrent is currently the name there, application. And we would all share it without any kind of central server. And it's like super fast because everything is here in the room. So just to give you an idea about the timescale of such changes, the HTTP and the services that we have, they actually evolved over the time of almost 2014, about 25 years. Like Python is 1991, and HTTP, HTML is like 25 years, and Facebook is 11 years. So we have 11 years of Facebook, where it evolved to the state where it currently is in. And Elon Musk, who knows Elon Musk? Okay, he's one. What is he aiming at for 2026? Yes, for Mars. So he's actually trying to get a Mars station on there. There are some pictures on how they want to do this. And the problem is, how do you access web applications from Mars? It's an extreme case, of course. But sometimes my mobile phone is also on Mars. So the problem is it's really already there. But it's going to get worse. The connectivity problems we have and the service connection problems and the intermittent network problems, they're going to get worse all the time the more devices we have. And at latest, when you get like very far areas like Mars or so, there's no way you can actually still use this paradigm of going to a central service in order to interact and share things. And with the Internet of Things and bad connectivity and all of that, people on the web front, they're actually using to this content-based addressing and building platforms that don't actually need any kind of central point to coordinate. I can't go through all of the technologies that I have dived in, but it's my deep impression actually that this is going to happen, and it's going to happen in the next 10 years. And IPFS is like a chance also for Python to play a role, because if you actually have things running on the endpoint and you have IPFS, and that was demoed yesterday, then you can run on these endpoints all kinds of code, also not browser code, like server code, and you can put something into IPFS, and it's immediately available in the browser, and it's replicated all across the nodes. And you don't have to care about the underlying technology anymore, because the whole logic of Git and the hash-based data structures and all this, that's all basically done for you by just using IPFS, right? So that's really something like you can, for example, mount a file system on IPFS. You can access it from a browser, you can have it in your shell, and you can use it directly in your file system and have your application work with that, and it's going to be like available everywhere because it replicates around, right? And this is starting to work actually quite nice. There's some very impressive demos. And that's why I think that, that something like IPFS or IPFS itself is going to kind of like mark a shift on how you can build applications so that you don't actually rely on a center anymore, which is not just like a political question in terms of control of central platforms, but it's also a matter of network efficiency and speed and connectivity and security, because things are end-to-end encrypted all the time, right? So there's like a lot of things built into this kind of platform, and it's kind of like the abstraction that people gathered working in these fields from the last 6-7 years of developments. And yeah, so I think that the decentralization and centralization and this kind of topic, which is kind of difficult because you can view it on the social level, on the network topology level, on the ownership level, all kinds of levels on how you can see actually this pair. But if you just think about distributed architectures, I think these changes are going to happen. And actually, that's good. I think it's actually going to be good for Python. If, like, some people, like in the Node.js or JavaScript community, actually also start, like, dealing with the thing, and not just rely on, well, HTTP is going to be there, like, in 50 years as well, which I think is not necessarily true. Things do change. Even large companies go away. And one of the primary targets currently that the group yesterday had was like replacing and making kind of like GitHub obsolete, right? That sounds like crazy. I mean, you cannot do this. But I've seen the demo, and things actually start to work without a center, and you can do the same things. Have pull requests, have comments on pull requests, interact with people, and so on, and there's no center anymore. It's kind of like Git, but done like in a real way, where it's really distributed and allows the interactions without the centralized point of control. Okay, thank you.
Thank you very much for your talk, Holger. Are there any questions? Yes, there are.
So I have a few comments. First of all, the fix, how to help Elon Musk with the law here. so to help Elon Musk, I think that in the old dial-up modem days with Usenet, that it worked like first I downloaded only the headers, then mark the interesting articles, and then download the content. So that's a quick fix for guys at Mars. Just use Usenet and download.
But that takes a long time to actually interact, right?
That's a quick fix.
How do you do chat then between people on Mars?
No idea, but they could start with Usenet, right? And we killed that, yeah. And or maybe.
Well, Snapchat is also an application of like peer-to-peer architectures. So.
And now the question. With this content hashes, I think that we still need a search engine or central database of the links, right? Because it's hard to guess the hash, right? To get some content. So if I'm a blogger, I have a blog post on my server or not, I have to share the link somehow, right? For instance, on Twitter, on Facebook, or.
Right. I mean, you can actually build something like Twitter and communication platforms on these kind of like emerging architectures. So you can actually talk to other people and broadcast your information. And then it depends, like, for example, if you want to have like a GitHub replacement that works on your endpoint, always locally, always fast, always there, including like doing multiple pull requests and then syncing when you get off the train, and everything gets automatically merged. And people see actually the pull request comments and stuff like this. When you do this, then there is software running on the endpoints, and that's going to be written by people, right? And what this software does in terms of going to some kind of registry or adding something to a list so it becomes searchable, that's totally possible, right? The things you can do now, like indexing multiple things, you can still do that. It will become harder, I think, for Google to exhaust the whole internet and walk across everything, right? So it's not like a total solution to the search problem, but in terms of finding something on GitHub or all kinds of other platforms, that's possible. And there's certainly room for new standards, and there is going to be a fight. I mean, GitHub will not like developers actually adopting this, right? Because they're just left out completely from this. And also other entities who are currently big players, they will not easily adopt this. So if Google actually adopts this kind of thing in Chrome, it's not clear yet. Although there are some contacts to people from Chrome who are actually interested in this. So it's kind of a mixed situation, but it does, of course, harm some current profit interests. But the search is definitely possible, I think.
Okay, I have a question. Who's now? Okay. This is actually about immutable content, right? So what happens if something actually should change? Yes. So how do we distribute, like propagate information about change?
Right. Yeah. Very good question. What I talked about was IPFS. There is also something called IPNS, which I didn't discuss yet. And it actually maps the domain name system, DNS, and other naming systems inside human-readable content. And when you interact through IPNS, you can actually talk to something that is mutable state.
Okay.
Right? So it's kind of like an indirection. The IPNS actually is also a distributed architecture, but it actually maps. It gives you basically for some human-readable name, it gives you the content hash, right? Or one thing that also what is very nice actually, when you have this content hash, and then you update the website, I can still have the exact version of that website of the content by just using that hash. It's like using Git to go to a certain branch, because you can implement Git on IPFS if you like, and people are actually doing that. But okay. The thing is that the content hash is like one view of the system and how you can get like correct references everywhere. And IPNS actually is the layer that does what currently DNS does between names and IP addresses, but with IPFS it's names to content hashes.
I have a question here. Holger, this way.
It's impossible.
I don't know if you know, but CNRI, where Guido used to work in the US in the early days, they had a protocol invented called the handle protocol.
What?
The handle protocol. Mm-hmm. And that is pretty much very similar to what you're currently talking about here.
Yes.
And the Grail browser I talked about in the keynote today was the first browser that actually natively implemented that handle protocol.
Oh, I see.
But the point I wanted to make is that protocol was not very successful.
Well, but I mean, the thing is that all kinds of protocols haven't been successful, and for example, content hash-based data structures, they have been used in the 80s, they have been used in the 90s. So you could actually argue, oh, but you know, it doesn't work. But then came Git and other things, and BitTorrent and whatnot, and suddenly it worked. People said for 200 years, oh, we're never going to fly. Every time we try to fly, we crash, right? But at some point it worked. So I think this argument, just because there are failed attempts of doing something, does not mean that it doesn't eventually happen. And the pressure from the Internet of Things and bad connectivity and remote places is really increasing. So this is like a big problem.
Well, I mean, even if you have this new way of addressing things, you still got to get the data to the people, right? I mean, if you're on Mars and your data blob doesn't happen to be on Mars,
yeah, sure. You still have to get it.
Wait for that data blob to get there,
yes.
right?
But all the applications that build on top, they actually make use of like this efficient replication technique. So if the first person actually looks at some website and gets the content, and then the second person comes along and wants to get it, this person will just get it locally. And that's like automatic, right? And if you have applications that work like this automatically, just by using IPFS : something, then applications are going to use it, and they all benefit from this because it's a global shared namespace. So if you access through your Python native application some things, and I use the browser, I will use the cache. And there's no need for any kind of library that you have to link in or something, right? It just works. And that's kind of a proposition that, if you look at the demos on IPFS and other things, it's really impressive on what you can do with this already, right? And it's still emerging, of course. It's lots of experiments still going on. But it's based on real-world applications, and it's extracting the data structures that are already used in production all across the globe and like massively, and extracting this and making this kind of a standard so everybody can use it, right? That's the idea.
I have two questions.
Yes.
The first one, how do you solve the situation when there is a hash collision? And the second question is, how do you make the data persistent? So if one person turns out his computer where there was the shared data, how do you ensure that there is somewhere copy of this data?
Say the first question again, sorry.
Hash collisions.
Well, yeah, you use a hash that doesn't have collisions. I mean, that's so you don't just use a like.
If I may answer to your second question, which was how do we store data? I think very important a very interesting point to start is Project Ethereum, which is very related to Bitcoin and already today gives technical possibilities of doing distributed Dropbox, distributed computations, and a lot of distributed things that is way unexpected that you can just build it as easily. And as you mentioned, a lot of properties. Project Ethereum already takes care of shared code, already takes care of shared data, already make sure that there is incentives for players in the network to actually store your data, to actually do the computations.
Yes. Just one side note on this Ethereum reference. In this peer-to-peer and distributed application space, where like yesterday I heard, the last 2 days I heard like 20 talks and lots of discussions. Bitcoin is really just one area, and the idea that you build everything on Bitcoin is not the main idea of the current thing what's going on. The idea is to use the data structures that all of these distributed architectures use and extract them and make them like raise the level, like we did in Python with like having dictionaries and lists and objects, right? And raise this, but adapt it to the distributedness that we have on the net. And that blockchain plays a role, but just in one corner. It's not like the system where everything builds on. And there's like a whole different talk on why this is so, but I think this is my kind of like my thinking and what I understood talking to people.
Okay, this was the last question. Thank you very much for your talk, Holger.